For section 1, we are going to be finding the missing angle of the triangle. So just a refresher, we know that angle X plus angle Y plus angle Z is going to equal 180 degrees. All right, so let's look at number 1. We have 78 degrees, 37 degrees, and then we have a missing angle. So we're going to do 78 plus 37 plus B should equal 180. So first we're going to go ahead and add 78 plus 37. So 78 plus 37. 8 plus 7 is 15. 7 plus 3 is 10. Plus 1 is 11. So 115. So 115 plus B should equal 180. We can go ahead and draw our balance. So our inverse operation is going to be to subtract 115. So I'm going to do that to the other side. 180 minus 115. So B equals, so 0 minus 5 we're going to have to borrow. 8 becomes a 7. 0 becomes a 10. 10 take away 5 is 5. 7 take away 1 is 6. And 1 take away 1 is 0. So our missing angle is 65 degrees. All right, so next for number 2, we have 80 degrees, 66 degrees, and our missing angle. So we have 80 plus 66 plus R should equal 180. All right, so let's start by doing 80 plus 66. So 80 plus 66. 6 plus 0 is 6. 8 plus 6 is 14. So 146 plus R equals 180. So I'm going to draw my balance. I'm going to subtract 146 on both sides. All right, so 0 take away 6, we're going to have to borrow. Our 8 becomes a 7, 0 becomes a 10. 10 take away 6 is 4, 7 take away 4 is 3, 1 take away 1 is 0. So our missing angle of R is 34 degrees. For number 3, we have 35 degrees, 28 degrees, and a missing angle. So we have 28 plus 35 plus L equals 180. So let's start by doing 28 plus 35. So 28 plus 35. So we have 8 plus 5, which is 13. And 3 plus 2 is 5, plus 1 is 6, so 63. 63 plus L equals 180, so I'm going to draw my balance. I'm going to subtract 63 on both sides. So 0 minus 3, I'm going to have to borrow. So 8 becomes a 7, 0 becomes a 10. So 10 take away 3 is going to give me 7. 7 take away 6 is 1, and 1 take away nothing is 1, so our missing angle is 117 degrees. All right, for our next set of questions, we are going to list the angles from least to greatest. Well, if I notice on this first problem, I do not have the angle measurements. But we know that there is an angle-side relationship in a triangle, and I have all of the side measurements. So I can use my side measurements to help me. The largest side is across from the largest angle. The smallest side is across from the smallest angle. So we're going least to greatest, so I'm going to find the smallest side. So from R to Q, that's my smallest side of 4 meters. So I'm going to go straight across, and I see angle P. So angle P is the smallest. Next I have 6 meters. So side PR, I'm going to go straight across, and that's going to give me angle Q. And then my largest side, PQ, which is 7 meters, I'm going to go straight across. So my largest angle is angle R. All right, I'm going to do the exact same thing on the next 2 problems. So my smallest side TU, I'm going to go straight across, and I have angle S. And then my next smallest side, ST, I'm going to go straight across, that's angle U. And then my largest side, SU, I'm going to go straight across to angle T. All right, last one. So smallest side, KL, go straight across. It's going to be angle J. Then I have 13, which is side JK, go straight across, angle L. And then 15 centimeters, so JL is the longest side, or the largest side, go straight across to angle K. All right, so next we have list the sides from least to greatest based on the angles. So this time we have the angle measurement and not the side. So we're going to do the same thing but just backwards. So I'm going to look at the smallest angle and go across, and it will give me the smallest side. So 50 degrees is the smallest, so angle W is the smallest. I'm going to go straight across, so UV, side UV, is the smallest. Next we have 60 degrees, so I'm going to go straight across. So then I have side VW. And then next I have 70 degrees, so I'm going to go straight across, and that's side UW. All right, for the next problem, 35 degrees is the smallest, so I'm going to go straight across. So I have side PQ. And then I have 50 degrees, so I'm going to go straight across. So next I have QR. And then 95 degrees is the largest, I'm going to go straight across, and that's side PR. All right, for the next set of problems, I'm going to identify each type of triangle with two names. So first, I need to choose a name based on the sides. So it could either be scalene, isosceles, or equilateral. And then it also has a name based off its angles. So it could be right, obtuse, or acute. So for the first one, right here, if we look at the sides, 6 inches, 5 inches, 3 inches, they're all different. So that is going to be a scalene. And then based on the angles, we notice a right angle here. So it's a scalene right triangle. All right, next, for the next triangle, we have 10 feet, 15 feet, and 16 feet as the side lengths. So none of them are the same. So again, we have a scalene. And then if we look at all the angles, 66 degrees, 54 degrees, and 60 degrees, those are all less than 90 degrees. So those are all acute angles. So this is a scalene acute triangle. And then last, we have the sides, 20 centimeters, 10 centimeters, 11 centimeters. Those are all different. So that's going to be scalene again. And then it looks like we have an obtuse angle in here, 125 degrees. That's greater than 90 degrees. So this is a scalene obtuse triangle. All right, for section 2, we're going to be looking at supplementary and complementary angles. So we need to find the missing angle. So we first notice that this is a straight line. So that's 180 degrees. Well, that is going to be a supplementary angle, and remember, the S turns into an 8, so that's how we remember supplementary is 180 degrees. So I know that X plus 70 should equal 180 degrees. So I can draw my balance here, subtract 70 on both sides, X equals, so 0 take away 0 is 0, 8 take away 7 is 1, and 1 take away nothing is 1. So I know the missing angle here is going to be 110 degrees. Now on this next problem, we notice that this is a 90-degree angle. So this is going to be complementary. Remember, the C turns into a 9, and then we can add a 0. Now this problem actually is already done for you. We have 41 degrees and 49 degrees, so I just wanted you to know that that is a complementary angle. So these two should add up to 90 degrees. All right, for section 3, we're going to be finding the area of shapes. So we're going to find the area of each shape. Use your formula chart. So if you don't have a formula chart with you, you can definitely find that online. You can just Google 6th grade star formula chart. Okay, and you will have this available for you on your test tomorrow. All right, so the first shape we have is a triangle. And we know that the formula is going to be area equals 1/2 times base times height. Now we talked about in class how that is the formula you're given, but we know that multiplying by 1/2 is the same as dividing by 2. So you can also use the formula area equals base times height divided by 2. All right, so let's plug in our numbers. Area equals, we have our base right here of 16. And then we have our height. Remember, height is going to be straight up and down, so that's 7. So 16 times 7, and then divided by 2. All right, so let's go ahead and do 16 times 7. So 7 times 6 is 42. 7 times 1 is 7, plus 4 is 11. So we have 112. So we have our area equals 112, and we're going to need to divide that by 2. So 112 divided by 2. 2 doesn't go into 1, but it goes into 11 5 times. 5 times 2 is 10. Subtract and get 1. Bring down your 2. 2 goes into 12 6 times. 6 times 2 is 12. Subtract and get 0. So our area is going to be 56 meters squared. All right, the next shape we have is a parallelogram. It has two sets of parallel sides. These sides are parallel, they will never intersect. These sides are parallel, they will never intersect. So that is a parallelogram. So the formula for a parallelogram is going to be area equals base times height. So let's go ahead and plug those numbers in. Area equals, we have a base of 11, and we have a height, which is straight up and down, of 6. So 11 times 6. So my area is going to be 66 miles squared. All right, next shape is a trapezoid. It only has one set of parallel sides. So these sides are parallel, they'll never intersect. But these sides right here are eventually going to intersect. So this is a trapezoid. So the formula for a trapezoid is going to be area equals 1/2 times base 1 plus base 2 times height. Now we talked about in class how multiplying by 1/2 is the same thing as dividing by 2. So I'm going to rewrite this as area equals base 1 plus base 2, multiply by the height, and then divide that all by 2. Okay, so let's go ahead and plug our numbers in. Area equals, so base 1, 2 feet, plus base 2, 4 feet. That's going to be multiplied by the height, which is 3, and then divide that all by 2. All right, so let's go ahead and do what's in our parentheses first. So 2 plus 4 is 6. That will be multiplied by 3, and then everything will be divided by 2. All right, so 6 times 3 is 18, so area equals 18 divided by 2. So my area will equal 9 feet squared. All right, our next shape is a rectangle, so that is going to be area equals base times height. So plug in our numbers. So area equals 4.5 times 8. So when we multiply by decimals, remember we don't need to worry about the decimal. We can leave it out and bring it back in at the end. So let's go ahead and do 45 times 8. So 8 times 5 is 40. Sorry, that's a 0. 8 times 4 is 32, plus 4 is going to be 36. And then we had one number behind the decimal, so we need to have one number behind the decimal, so we will actually end up getting 36. So our area is going to equal 36 feet squared. All right, next we have a triangle. So I'm going to use the formula from earlier. Remember, area equals 1/2 times base times height, but we know that also can be base times height divided by 2. So area equals base times height divided by 2. All right, so area equals, my base is 4.5, so 4.5, and my height is 4, so times 4, and we're going to divide all that by 2. All right, so same like the last problem, we have a decimal. I'm going to just go ahead and not worry about the decimal right now, and I'm just going to write 45 times 4. So 45 times 4. So 4 times 5 is 20. And 4 times 4 is 16, plus 2 is 18. We had one number behind the decimal, so one number behind the decimal in our answer. So that's 18. So area equals 18 divided by 2. So our area will be 9 meters squared. All right, and the last shape we have here is a trapezoid. And I'm going to use the same formula from right above it, so that trapezoid right above it. Remember we had area equals 1/2 times base 1 plus base 2 times the height, but we also know that it can be area equals base 1 plus base 2 times height divided by 2. So I'm going to use that formula. So area equals base 1 plus base 2 times the height divided by 2. So I'm going to plug those numbers in. So I have base 1, so 22, plus base 2, which is 13. I'm going to multiply that by the height, which is 5, and then everything will be divided by 2. All right, so let's start with the parentheses. So 22 plus 13. So 22 plus 13. 3 plus 2 is 5. 2 plus 1 is 3, so that's 35. So area equals 35 times 5, and then all of that will be divided by 2. All right, so I'm going to do 35 times 5. I'm going to go to the top of this to work that out. Sorry, I'm running out of room. So 35 times 5. So 5 times 5 is 25. 5 times 3 is 15, plus 2 is 17, so I get 175. So my area equals 175, but then I have to divide that by 2. So once again, I'm going to go back to the top since I'm almost out of room. So 175 divided by 2. 2 does not go into 1, but it goes into 17 8 times. 8 times 2 is 16. Subtract and get 1. Bring down the 5. 2 goes into 15 7 times. 7 times 2 is 14. Subtract and get 1. I'm going to add a decimal, bring it up. Add a 0, bring it down. 2 goes into 10 5 times. 5 times 2 is 10. Subtract and get 0. So we have 87.5. So our area equals 87.5 feet squared. Sorry, it's a little hard to read that, but once again, that's area equals 87.5 feet squared. I'm going to write. All right, for the next section, we are going to look at volume. And the formula for volume is volume equals big B times H. And we talked about how the big B is really the area of the rectangular base. So we are going to write that as length times width times height. So volume equals length times width times height. All right, so let's look at the first one. I'm going to rewrite that formula. Volume equals length times width times height, and I'm going to plug those numbers in. Volume equals my length, so 13 times my width, 5, times my height, 8. So let's start with 13 times 5. So 13 times 5. 5 times 3 is 15. 5 times 1 is 5, plus 1 is 6, so that's 65 times 8. So now we're going to do 65 times 8. So 8 times 5 is 40. And 8 times 6 is 48, plus 4 is 52. So I have volume equals 520 meters cubed. All right, so next we have, same thing, we're finding the volume, so volume equals length times width times height. So let's plug in our numbers. So my length, 2, times my width, 3.5, times my height, which is 8. All right, let's start with 2 times 3.5. So I'm going to write it just as 2 times 35. I'm going to leave the decimal out. So 35 times 2. 2 times 5 is 10. 2 times 3 is 6, plus 1 is 7. I had one number behind the decimal, so one number behind the decimal. So I'm going to have 7. 7 times 8. So we will end up getting our volume. So 7 times 8 is going to give us 56 meters cubed. All right, and our last one, so volume equals length times width times height. So let's plug our numbers in. So 4 times 4 times 4. So first, 4 times 4 is 16. So now we're going to do 16 times 4. So 16 times 4. 4 times 6 is going to give us 24. 4 times 1 is 4, plus 2 is 6, so we're going to get 64 inches cubed.